Good afternoon to all of you. Myself Dr. Sarita Kumbhar. Here I delivered the lecture on the paper Thin Solid Film Deposition and Properties from MSc second year semester 3rd. This slide shows the syllabus of MSc second year from semester 3rd which regarding NAP 2020. This semester contains 4 theoretical papers. First is the statistical mechanics, second is the atomic and molecular physics, third one is the thin solid films deposition and properties, and fourth one be the special materials. Out of these 4 papers here I discuss thin solid films deposition properties. This paper contains 4 units. Unit 1 be the physical method of thin film deposition. Unit 2 chemical methods of thin film deposition. Unit 3 nucleation growth process and thickness measurement, and Unit 4 properties and characterization of thin film. Out of these 4 units, here I discussed the second unit chemical method of thin film deposition. This second unit consists chemical methods like chemical vapor deposition method, chemical bath deposition method, electrodeposition method, spray pyrolysis method, Silla method, sol gel method, and hydrothermal method. Before discussing this chemical thin film deposition method, first we are going to know something about thin films. So first we have to see what is meant by thin films. So thin films is a layer of material ranging from fraction of a nanometer to several micrometer in thicknesses. Okay, so why we need these thin films? What is the need of thin films? So first, thin films maintain surface uniformity as compared to bulk material. These are simple in fabrication. Their manufacturing require less material. These are light absorbing materials. Thin films are strange in electrical, optical, and mechanical properties as compared to the bulk material. This slide shows the classification of the thin film deposition methods. The thin film deposition methods are classified into 2 types. First is the physical method, another is the chemical method. Here we focus on to the chemical method of thin film deposition. Chemical method of thin film deposition again classified into 2 types: gas phase and liquid phase. We have to see all these methods one by one. This is the setup of spray pyrolysis method. This is the chemical deposition method and which is in liquid phase. So first we have to see principle of this spray pyrolysis method. Principle: the spray pyrolysis is a process in which a thin film is deposited by spraying a precursor solution on a heated surface where the chemical ingredients react and to form a chemical compound. This figure shows the schematic diagram of the spray pyrolysis method. This method consists of the spray nozzle, air compressor, solution bath, temperature controller, electrical supply, heater, substrate, heating or electrical arrangement. We have to see one by one all these components and their mechanism. First is the spray nozzle. Spray nozzle is here in this figure. This is the spray nozzle. So what is about this spray nozzle? The spray nozzle is made up of glass and it consists of the solution tube which surrounded by the glass bulb. In the application of the carrier gas pressure, the vacuum is created at the nozzle tube and this solution is automatically sprayed onto the preheated substrate. Here, this is the solution. In the solution bath, the solution comes from this capillary and suddenly here the air compressor and air comes to this capillary and the atomization is take place at the tip of the nozzle and the spraying process is start by using the nozzle. Second one be the rotor for spray nozzle. Rotor is here. This is the microprocessor assembly which shows the motion of the nozzle like a left and right. So here is the rotor for spray nozzle. The stepper motor based microprocessor controller is used to control the linear simple harmonic motion of the spray nozzle over the required length of the hot plate. Another one is the liquid level monitor. Liquid level monitor is here. It is the liquid level monitor. Here we kept the solution which is spray. So liquid level monitor indicate the change in height. Liquid level monitor indicate the change in height of the spraying solution and how much a solution sprayed out. Another is the hot plate. Hot plate is here in this figure. See the figure. Here is the hot plate. Here is the hot plate. So what is the mechanism of the hot plate? Stainless steel hot plate is used to measure the temperature of the substrate. The chromal aluminum thermocouple is used and it is fixed at the center of the front side of the hot plate. Another component is the gas regulator valve. To control the pressure of the carrier gas flowing through the gas tube of the spray nozzle, the gas regulator valve is used. The airtight chamber is used for the evolution of number of toxic gases take place during the thermal decomposition of the spray solution, and it is necessary to fix the airtight fiber chamber inside the spraying system. These are the different components of this spray pyrolysis setup. This setup is available our lab also. So we have to take all depositions of or prepare the thin films by using this spray pyrolysis method. But by using this method, how actually the thin film was prepared. Here this slide shows the mechanism of thin film formation by spray pyrolysis method. There are 5 different stages as shown in figure. The first stage here is the droplet conversion. The first step, an aqueous precursor solution is converted into aerosol droplet. Then thereafter their precipitate and vaporization take place. In this step the vaporization of the solvent leads to formation of the precipitate as the droplet. Here as shown, droplet is converted into precipitate and their vaporization will take place. Another pyrolysis of the precipitate occurs in before the precipitate reaches to the substrate. Here is a pyrolysis pyrolysis decomposition occurs. So what is meant by pyrolysis? Pyrolysis means it is the in the application of the temperature, there is a thermal decomposition of the chemical ingredients. So this is the pyrolysis decomposition occurs in here. Another step is when the precipitate reaches the substrate, nucleation and growth of the films take place on the surface of the substrate. Here first the aerosol formation. The aerosol formation is regarding take place into evaporation and precipitation. Another thereafter vaporization or precipitation. Here is a solidification take place. And after the finally a thin layer of material or nucleation and growth of the thin film take place onto the substrate. Hence the last stage at the end, the growth of the nuclei lead to the formation of continuous thin layer of a metal oxide thin film. So this is the proper mechanism of the thin film formation in spray pyrolysis method. This is the advantages of spray pyrolysis method. The spray pyrolysis method is most popular today because it is low cost and simple method for preparation of oxide and semiconductor thin films. Apart from its simplicity, the spray pyrolysis method has number of advantages. It produces large area, high quality and adherent thin films with uniform thicknesses. Spray pyrolysis method doesn't require the high quality targets like substrate and does not require vacuum at any stage. Then the layered films can be prepared by changing the composition of spray solution during the spray process. And the last one, the deposition rate and thickness of the film easily controlled. So this is the spray pyrolysis system. Another chemical method is the chemical vapor deposition method. This is a chemical method but it is in gas phase. The spray pyrolysis is also chemical method but it is in liquid phase. But here it is the gas phase. So first of all we see what is the principle of CVD method. So principle, chemical vapor deposition method is a coating process that uses thermally induced chemical reaction at the surface of the heated substrate with the reagent supplied in a gaseous form. How we can see in next slide what is the actual process, what is the mechanism, how this thin film is synthesized or prepared by using this technique. So we have to see one by one. So the process of deposition of a solid material such as the nanowires, nanotubes, particles or thin films on a substrate by the generation of reactive species in the gaseous phase is referred as a chemical vapor deposition. Here we have to refer gaseous phase of our compound, our chemical. So how we can see in next slide. When precursor gases come in contact with the heated substrate, a reactive species is generated. There are number of CVD forms that include atmospheric pressure, chemical vapor deposition, then metal organic chemical vapor deposition, and also low pressure chemical vapor deposition. Metal organic species are used as a precursor to thin film of a metal oxide, metal nitride, and other kind of metallic compounds. So this is the actual setup, experimental setup of CVD thin film deposition technique. This method is this experimental setup is available in Shivaji University Kolhapur. I also try to develop this setup onto our lab also. So this is the CVD method. Here is this method is developed by using raw materials. This method is developed by using raw materials like floored tin. Here we have to take आपण दोन रॉ मटेरियल फक्त पिठाचे दोन डबे घेतलेले आहेत आणि त्याचा यूज आपण ॲज अ कंटेनर म्हणून केलेला आहे. हियर इज अ वन कंटेनर, हियर इज अनदर container. In one container, here we have to insert our sample. In another container, here we have to insert our substrate. If this container attached into two temperature controllers, here I have given the temperature of these both controllers. Okay, and here is our liquid sample. We have to insert the liquid sample into that container. Then suddenly here the temperature is running, and here according to their proper temperature, this liquid is vaporized, and this plasma is created, and this is deposited onto the substrate, which is inserted onto that container. So this is the basically mechanism of the chemical vapor deposition. Here is a one cylinder used because of during this chemical vapor deposition method we have to use the gases like argon, nitrogen because of a catalyst. Okay, they are used as a catalyst. This is the mechanism of this is the mechanism of the chemical vapor deposition method. Here the film growth and the release of volatile byproducts. Here the adsorption take place, reagents in a gas phase. The role of this component is to generate vapor precursor and then deliver to the reactor. The design of the CVD reactor depends on whether the starting material is solid, liquid or gas. The sublimation of a solid precursor depends on the surface area on the solid and contact time. Liquid source often use bubbler to vaporize the reactant. जसं की आपण मगाशी सांगितले की कॅटलिस्ट म्हणून आपण आर्गॉन किंवा नायट्रोजनचे गॅस किंवा सिलेंडर्स तिथे यूज करू शकतो. That's like the liquid sources often use a bubbler to vaporize the reactant and a carrier gases like hydrogen, argon, nitrogen to transport the vaporized reactant into the reactor. These are the advantages of the chemical vapor deposition method. CVD can deposit films with high purity and uniformity. The precursor gases can be purified to remove the impurities and ensure high quality films. The deposition process can also be controlled to ensure uniform thickness and composition of the films. CVD is a highly scalable process, which means that it can be used to deposit films on a larger substrate. This makes CVD ideal applications where large area coating are required, such as in a solar industry. CVD is a relatively cost-effective process, especially when compared to other deposition techniques. CVD films typically have a low defects density, which make them ideal for application where high quality films are required. CVD can be used to deposit a wide range of material including metal, ceramic and polymers. Thank you.